robot always freaks me out. Like, why? But cool. And this is just to kind of give you an introduction to object-oriented programming. We'll go more in depth later this afternoon and talk about like relationships and actually associating objects with each other. But for now, it's just an intro session. And I got my README notes. And typically, I like to also use this time to like ask if there's any questions about this topic, either you saw from the labs that are still kind of unclear, so that I can kind of target it during the lesson today and make sure that we cover that subject or concept more in depth. I know it's the first one, so it could be kind of like you're still working through labs and getting used to the structure and just getting used to like the school structure for today after getting back. But if is there anything like about object-oriented or before that's hazy to you that you want to talk about today? Cool. Go ahead and get started then. In the beginning, or yeah, we'll look at this hash structure later. Our bats for the day is just to get familiar with the concept of what objects are, how are they represented in Ruby, and getting used to a lot of convention between working with objects in Ruby and getting used to convention and terms that we're going to use, and also getting used to syntax. So that's going to be the goal of lecture today. I don't think we'll get through all of it, but we'll get through as much as we can and pick it up in our afternoon lecture. And I usually like to give breaks for students in between. I know this lesson itself is like an hour and a half long, which could be a lot, just sitting and like staring at a computer. So I put a timer for after like 45 minutes. So you can kind of like get up and stretch in between 10 to 15 minutes, and then we'll come back and finish up the remainder of the lecture. It's going to be a combination of you writing code on your own, and also sometimes I assign breakout rooms again, and then you'll work on kind of like a small task together as a group, and then we'll come back together and figure out a solution and where to go from there. Cool. All right. To get started on even before we like dive into code, I usually like to give an introduction behind like the why we have object-oriented programming and go over real quick the 4 pillars of object-oriented coding. So when we talk about object-oriented programming and design, it's one of the main goals in Mod 1. If you're like, why are we in Mod 1? What are we doing with Ruby? Why are we using Ruby? Questions like that is driven a lot by teaching you how to get comfortable with domain modeling. And we'll kind of go into more on that later in about a couple minutes. And also getting comfortable with the idea of abstraction and encapsulation, inheritance, and polymorphism. So if you're like, the goal behind Mod 1, what is it? This is the goal. And the 4 pillars of programming is something that's a very high level concept that's here. You don't have to feel like you need to be an expert in it. It might be your first time seeing these concepts. Totally okay. It's just something that you need to be familiar with in the world of computer science. So that's the first part, getting comfortable with these concepts and how we represent them in Ruby. And the second part is relationships, which is really where the power behind working with objects comes in to play in Ruby and just in the world of coding. And this we'll kind of dive into later this afternoon. And even taking a look at this, inheritance and polymorphism is something that we're not going to get into too much in depth in the world of Mod 1. I want you to keep that in mind. Polymorphism is definitely one of those concepts that are going to be more advanced, and it'll make more sense once you have a handle on object-oriented programming, what it is, and the concepts before. And inheritance, we'll get a slight introduction as we start working with like frameworks that are available to us in Ruby, but we're not going to dive too much into inheritance. So don't worry about these two. You don't have to be like super comfortable with inheritance or polymorphism to be successful in the world of Mod 1, or even really in the world of coding sometimes. But abstraction and encapsulation are the 2 major points that you need to get comfortable with when you're coding out your Ruby objects. Now, I want you to focus more on figuring out how you can abstract data, abstract objects, and represent them in code. I don't want you to focus so much on the syntax, the fact that we're coding in Ruby. Technically, you can also represent these concepts in JavaScript. Any other object-oriented programming language, Java, C++, technically that you're gonna work with, is gonna have these concepts in there. So the why behind this, don't focus so much on like syntax and languages. Focus more on getting these concepts down. So that's the goal. So sometimes if you're like, don't know how to do this in Ruby, the syntax you'll kind of get used to over time. Any questions on this? Like awkwardly pause for 5 seconds every time. Feel free to speak your mind. And today we're going to be working on abstraction and encapsulation. So how can we take these concepts that are available to us and represent it in Ruby? That's the goal for today. All right. And this sounds like really fancy. I read through this and I was like, I don't like the example too much. But really, when we talk about abstraction, it's just taking a look at any real life object that's out there and representing it as data and representing it as code in our programs. And you'll get comfortable with this. If you're new to coding, this concept is super weird. And you're literally changing the way you're thinking as you transition into being a better developer. Because you never like look at a table and you're like, all right, let me figure out all the properties and the behavior of a table. What can it do? And translate it into code. It can be really weird in the beginning. So be patient with yourselves. You'll get comfortable with abstraction over time. And then encapsulation, you're kind of comfortable with it in files that you've been declaring. It's just the idea that everything that you create inside of the class is only available within the class itself, which we'll see in code later in lecture today. All right. And I'm gonna kind of like dive deeper into abstraction and get some practice with how we can start with some random object and get to code. Cool. I'm using this, you can use any like drawing tool that's out there available to you. I'm using this one called Creately that I randomly found on Google. It was like the second link and I was like, cool, I'm gonna try it out, and it works out. Just a tool for you to draw diagrams, to visualize your data. You can write text, and that's mainly what I'm gonna be using it for. You can use Paint, you can use any other tool out there. But the main part is I wanna be able to take a look at some random object out there and define some properties and behavior for it, and then figure out a way to visually represent it, and then we'll write out the code for it. So someone just shout out like the first object that comes to your mind, and we'll code it out.
A cell phone?
Cell phone, okay. That's a very complex model. We'll do it. Cell phone. So this is our object. We're taking a look at a cell phone. And what are some properties of the object? So properties are things that describe the object, not particularly what it can do, but that will describe it.
Color.
Color. Cool.
Size.
Size.
Brand.
Yeah. Did I also hear shape? Did I hear RAM? Cool.
Brand. Sorry.
Oh, brand. I'm sorry. I'm Brad. I'm Brad. I was like, wow, RAM, so deep. Okay. Brand.
Plastic.
Was that plastic?
Yeah, or whatever it's made out of.
Material might be good.
No. Material. I can't spell, so don't judge my spelling. I'll make all these lowercase. Sweet. Oh wait, did I hear one more?
Doesn't say like screen. Would screen be something? Or...
So like, does it have a screen? Does it not have a screen? Like Nokia age, maybe?
Yeah.
Okay.
Buttons or no buttons?
Maybe I'm just showing my age.
No buttons. Cool. Sweet. So we got some properties. Took a cell phone apart, abstracted out the properties for it. Now, what I want to point out here is when we're writing this template, so now we have a template that represents a cell phone. We're saying every cell phone that's going to exist now has a color, size, shape, brand, material, and screen associated with it, which makes sense because if we had to fill this out for every cell phone we create, totally reasonable because it can't exist without this. So I feel like this represents the properties of a cell phone very well. So that's the first part, defining the properties for it. I'm gonna ignore spelling to save time. And then the second part is the behavior. So what can we do with a cell phone, or what can a cell phone do? That makes more sense. So what can a cell phone do for us?
Take pictures.
Talk on it.
Take picture.
Calls.
A long list.
Walls. We'll just take a couple.
Apps. I was gonna say generically internet.
Internet.
Messages, like SMS messages.
Oh yeah, text. That's also important. All right. My computer's freaking out. No, don't be crossed out. Oh well, I don't know why that happened. All right, so that's enough for now. We're saying probably like the most used thing for cell phones: internet calls, taking a picture, and text. Like basic essentials of what a cell phone needs to do in order for us to have it. Cool. So this is like firsthand, and these are behaviors. Firsthand example of what abstraction is. Not too bad. We're able to take some random object out there, define properties for it that we're gonna say is abstract enough to be applied to every single cell phone that's ever created. So that's the important thing to realize here. These are properties that are going to belong to every single instance of the cell phone that gets created in this world. And we're also saying every single cell phone needs to be able to take a picture, make calls, have internet, and text. And if we take it a step further and define how this is going to be represented inside of our Ruby programs, all of our properties are going to be represented as variables. And variables are something that you're familiar with seeing in Ruby inside of your methods. So we're familiar with the scope of local variables. We'll kind of dive deeper into different kind of variables that are available to us that we can use inside of our classes. And you'll see me also refer to these properties as attributes. So when I say attributes, variables, properties, they all mean the same thing. I intentionally use multiple different phrases to represent the same thing. So you're comfortable hearing all the different ways you can represent data inside of Ruby and just inside of classes in general. And all of our behaviors are going to be defined as methods. So these are things that our classes can do. These are actions in a sense that our classes can take. So every single behavior that you define for your object are going to be classified as methods. So this is a general pattern that you're going to follow when you're abstracting your object and trying to figure out how you're going to build this out in your code. I'll pause if there's any questions on this. All right, now let me draw an arrow. I'm still getting comfortable with this because I've only used it like a couple times. But there is some squiggly arrow, and now I'm gonna draw, paste this like diagram in. This diagram is representing it's basically a visual representation of my model. So I am a very visual person. I like to see a visual representation of basically every single model that I create. This is known as a UML object, and UML stands for Unified Modeling Language. So it's a standard language that's out there for visualizing your classes and your models that you're going to represent eventually in your database, but for now, in the world of Ruby. You'll also hear this referred to as an entity relationship diagram. Doesn't really matter what term you use, just a way to visually see the attributes and behaviors that we have. So this is going to become cell phone. Cell phone. And I'm not gonna write down all of this because we got a lot of stuff in here, but we'll code it out. But typically you're gonna say the name and the data type. Well, okay, never mind, I'll write it out, why not? Size is going to be an integer. Shape is probably going to be a string. Brand is probably going to be a string. Material, we're gonna say string for now. It can only be made of one thing. Screen, probably going to be a Boolean. We'll assume that if it's one screen, it doesn't have any buttons. New iPhone model. And then if it doesn't have a screen, it's all buttons, old Nokia models. And then all the things here, all right, and then the bottom section is going to be our methods. So this will be like take model, calls, internet, text. We'll probably find like better names for this because it needs to define like a behavior, like make call, connect to the internet, send text. Why did I write take model? Take picture. Take picture. But for now, I'll just leave it like this. Cool. And then we'll be using this as a guide to write out our class. So you can definitely get to a point where you're like, I don't need to do this. I can just code out my class. I'm comfortable with the syntax. You'll definitely get there. However, I don't recommend it. Always have an outline, always have a plan before you start coding. It's really good practice. And it just gets you organized before you even start writing code. So when you work on your final project in week 3, I typically require you to create these UML diagrams, so get comfortable with these now. I don't care which platform you use. You can even use Paint and like draw squares, paper and pencil, doesn't matter. Just get comfortable doing this for the models that you create. And ideally, when we're defining our objects, in the world of Ruby, this is a template of what a cell phone or what our object represents. So every single object that you're going to represent inside of Ruby moving forward is going to be its own class. It's going to be its own object. Sweet. All right. Any questions on this? Got a cell phone. Cool. So I want us to kind of get another practice with this. So I'm going to give you a chance to draw your own UML model. You can just do it in like paper and pencil, or do it in your head, or use Visual Studio Code, whichever you like to do. But I've been binge watching Avatar: The Last Airbender. I don't know if any of you have seen it because it's available on Netflix. It's great. So our domain for Mod 1 right now is going to be Avatar. And I'm sorry there's some spoilers that you see, but this is what we're going to work with.
I love that show. I love it.
Thank you. Thank you for the validation.
Yeah. My partner and I just finished season 1.
Ah, nice. I just watched The Northern Air Temple, and I'm midway through season 2.
Mm-hmm.
Yes, it's a great show. If anyone is like, I want to watch it. But yeah, we'll be working with Avatar: The Last Airbender, and the greatest part I like about Ruby and object-oriented programming, you can literally take anything and code it out. And that's a skill set that you'll get more comfortable with over time. But through that beauty, our programs will always evolve to basically take anything and build out objects with it. And today we're starting with characters. So I'm gonna pause probably around like 51. We'll write out our diagram for this. But take a look at our hash. I used a hash because hashes are the world that we live in. And they've been great so far, but there's really no way that you can abstract this out. Like with a hash, there's no way you can represent behavior because they're just data points that you see. So hashes are great for data, but to actually do stuff with it and build out programs, complex programs, it's not going to be very efficient. So we'll be kind of transitioning from the world of hashes into objects. So we'll be building out this object, and I want you to figure out, abstract this hash out, figure out what the properties are. I know there's no methods for this, so take a couple minutes, draw it out, and then we'll draw it out together. If there's any questions, let me know.
Oh.
My bad.
What else did you want us to look for? You said properties, attributes, and variables.
Yeah, that's just it for now. So properties, attributes, variables, they're all going to be the same thing. But that's about it, because with hashes, there's no behavior that we can define for our objects yet.
Okay, thank you.
Yeah, good question. So it's just going to be the top part of our model. Cool. So it's about 51. So I'll give you maybe about like 20 more seconds, and then we'll draw it out. This says dog from my last template. Ignore that. All right. Start wrapping up what your model looks like. Now let's draw out our UML diagram. And what we're doing here, real quick, I saw the term, is what domain modeling is. It's taking some object that we're going to work with and modeling out what our domain is going to look like. Domain typically stands for the subject of whatever project you're working with. So currently, this domain is, I guess, like cell phone or some cell world. The domain that we're now transitioning into, we can call it like Avatar, because it's all about Avatar, the Last Airbender. So domain is just whatever our subject is, and modeling is the act of taking that subject and representing it as classes in Ruby. So it's a lot of terminology, but you'll hear me say it over and over again, so that you get more comfortable with the syntax and terms that we use. So if it's not clicking right now, it's totally fine. So in the world of this, what should our model name be?
Team Avatar characters.
Team Avatar characters, sure. Avatar characters. And technically, Team Avatar characters, the way that we've defined it, is going to be our domain, because this is a list of all the avatar characters. So if this is our domain, what would our actual template of each model be?
Would it just be the characters themselves?
Characters.
It would just be the characters themselves. So domain and then character. So I'm gonna move this. Will it let me cut and paste? Nope. I'm gonna make this a character. Even though this is technically Team Avatar here, if I add in, let's see, Azula or some other random character, Cabbage Guy is great. Another random character that isn't part of Team Avatar, we still want to be able to represent inside of that, inside of our program, which is why character is going to be more accurate for the model name than avatar characters. Although this is our world, so that's our domain. Cool. And then we have name, home, and element. Those are going to be the attributes. String, home, element. They're all strings for now, which is fine. And then I'm going to take this out. And it's very common not to see your methods sometimes represented inside of your model itself. Since this is our class, we can put our models, but I would say 80% of the time, you'll see a lot of UML diagrams that just has the top part, which is fine. So it just has the model name and the character. Cool. Now let's go ahead and write out this object. I'm going to create a new file, and I'm going to call it avatar.rb. So I created a new Ruby file, and do I want to? I'll copy and paste this in here so we have access to it if we need to. And I'm going to quit out of this for now. So we took a look at this, and now we're going to create our template. We're going to create our class that says every character that I create is going to have these properties.
Mhm.
And this is going to be exactly in line with our diagram that we created. So we have a visual representation and we have our hash representation of the data that we want. In Ruby, you're gonna create a new class by just using the class keyword. So we're gonna say class character. And I want you to get comfortable with convention. Technically, you'll also see this be caps, but conventionally, your file names are gonna be lowercase. And your class is always characterized as a capital letter. So character, whatever class name you have, cell phone is always going to be capital. And anything within this class is encapsulated in a sense within character itself. So that's where the idea of encapsulation comes in. Everything defined inside of here only belongs within the character. And I'm gonna put a binding.pry so we can kind of like debug this as we go. And then I'll put a pry at the bottom. Cool. So now if I do Ruby avatar.rb, got my pry. Now as a review for pry, Ruby went through line by line by line. It added our character's array of hashes and it created our class character, and that's it. So if I type in characters, lowercase, I get access to the hash. So I have access to hash data in case we need it. And I'm gonna clear out the screen. I also have access to character. So notice I don't have anything in here, but in the world of Ruby, that's all it needs to define a character. Even though it's empty, it still exists in our world, which can be totally weird, but Ruby's great, you know, to do a lot of guessing for us. And it's like, yeah, this is a class, I'll take it. And since character is an object, there's gonna be some properties associated with it. Right now it's empty. And then there's gonna be some methods associated with it. And character automatically inherits from the class object or the object class in Ruby. So I can actually say class and it'll let us know, hey, this is a class, like a class object.
Mhm.
And something you can do with objects in Ruby is you can call methods on it, enter, and it'll give you a list of all the methods that are available to you to be used. So because it automatically is a class, you have access to all this stuff. We didn't write any of this. This is something that Ruby automatically gave us that is associated with a class variable. And you can do this with any object in Ruby. And that's kind of like the weirdest thing to get used to in the beginning. Every single thing that you create inside of your Ruby program is automatically an object. Similar to other languages, if you've seen others before, there's primitive data types and complex data types, which are objects. Ruby doesn't have primitive data types. So even as something as simple as two is an object in Ruby. So you can definitely say two.class, which is weird, like saying dot class and on an integer, but it tells you it's an integer object or an integer class. And two itself has a bunch of methods associated with it. Reading format is a little weird. I messed up my terminal. Yeah, go ahead.
Yes, not to get too off topic or too crazy, but is it technically an expression before we hit enter? That's what from one of the videos. So like if you type out 2, is that technically before you hit enter? That's considered an expression, and then when you hit enter, it actually turns into an object itself, or is it, or are they all objects?
I would say it's a combination of both, because Ruby is reading everything line by line and processing everything character by character. But I would say when we're in our pry session, 2 even on its own is still going to be represented as an object.
Okay.
Yeah, because even though we see 2, Ruby is always going to see an object when it processes that number. And technically, in your console, when you say expression, it can technically be an expression because this is just standard input until Ruby processes it.
Right. Okay, cool. Thanks.
Yeah. Cool. So we have, yeah, that's a good question. And what I want to say is sometimes you might be like, well, maybe not, but you might ponder, well, if 2 is an object, how am I able to say 2 plus 2 and get 4? Because now you're adding like 2 different objects together, and Ruby's somehow able to figure that out and give you this result. And it's able to automatically see this plus sign and add this together and give us a new 4, which is another object that's available to us. What I want to point out, when we said 2.methods, we saw this list of operations. So there's like greater than, equal to, and these are represented as symbols or references to methods that are available to be performed onto this. And one of this is plus. So what's actually happening is there is a method, the plus method, that's standard for objects in Ruby, especially for integers, that have the ability to add them together. So our plus is actually a method, and every single operation that you do inside of Ruby is basically just objects communicating with each other and sending messages to each other. So what's actually happening in the back end is there is a send method that's associated with every object in Ruby. And it's, say, the first part is the method you're trying to use, and the second part is the value that you're passing in, or the parameter for this specific method to be invoked. So this is our object that we're focusing on right now at this moment. We're gonna send 2 and invoke the plus method. Syntax speak can be kind of weird, but it does the same thing. So the main thing I wanna say here is every single method call, every single property, technically every single operation is just a send message that Ruby is doing in the backend. This is exactly the same as this. Questions, thoughts?
And that would be the difference between implicit and explicit, is that right? So like, or would that?
Yeah, technically this would be explicit, this would be implicit.
Okay.
Yeah. All right, so let's continue onwards. So main lesson there is everything in Ruby is an object. Because everything is an object, there's methods associated with it. Whenever you invoke that method, it's basically sending messages. That's how Ruby communicates with each other back and forth, or communicates in the backend. Sweet. And we have our character method that we defined, and we know that it's going to have a name, a home, and an element. So technically, if I want to give it a name, there's tons of different ways that I can do this. The most common way is to define methods to give maybe like access to those variables that I want to create inside of my Ruby. And I'll open the floor to maybe like one of you who wants to volunteer. If you've worked with like the object stuff inside of Ruby, any suggestions on how I can represent name, home, and element inside of this class?
The attribute accessor?
Attribute accessor. So, dang it, autocomplete. Adder accessor. And what does the adder accessor do?
It's like a reader and a writer?
Yeah.
Sorry if I butchered that part.
Oh no, that's correct. It's like a reader and a writer. Now let's unpack that even more. What's a reader and a writer?
Good question.
They're getters and setters.
Getters and setters. And what are getters and setters?
The setter is like the assignment, and then the getter is what we can call a setter. Or sorry, that might be confusing. But like as I see it as like a setter like assigns our variable, and then the getter is like we're like calling it inside of our class locally. I don't know if that's right.
That's cool. I like these. All of these are correct. And you can use adder accessor. I'm going to do everything manually for the first couple days so you can kind of see what the reasoning behind adder accessors are. Getters and setters, we're going to go over that and why we need them in the world of Ruby. So we know that name is going to have a variable. Let me see. Local variables. Comfortable with that. Name home equals an empty string for now. Element. This is completely unconventional. You'll probably never do this, but I'm just doing this to show a case. So don't get comfortable doing this. But we've defined a class. It has some local variables inside of it. And if we visit local variables, a couple of you pointed out during the HashiCorp lecture, our local variables are only scoped within the method or within the class. So nothing outside of this class has access to these variables. Exactly the same for classes that we create in encapsulation. It tells us outside of this class, no other person can get access to these variables by default. So let's say that I create a new character. So I'm gonna, oh wait, I'm still in my pry. Let me exit out of my pry. Avatar RB. And if I wanted to create a new character off of my template, so right now I have a class character. It's just a blueprint, a template that's available to me. I actually haven't created any instances of this character inside of my program yet. And a good analogy I typically use for that, or there's a couple different ones, is the blueprint house one. You can have a blueprint of the houses that you want to build, but until you actually build the house, there's nothing that exists. It's just a template that's available to be used. So this actually has like the reference here too. So the class is the blueprint, the instance is the house. Those distinctions are important. And then the other reference is the factory in a car. So you can have like one big factory, maybe like Toyota, a Toyota factory that has like a template for what all the Toyota cars should look like. And then the instance is the car, every single car that gets built, because every single car is unique. So that's the same idea behind our class. We have a template here, but we actually haven't built anything. We haven't instantiated anything. And we instantiate classes through the new keyword in Ruby. So let me say like ang equals character dot new. And every character that you build out is going to create an object. So the dot new, what it's actually doing is it's going into memory in a sense. It's finding a memory location and it's assigning that memory location to ang. So until you see this hashtag angle bracket with the memory address it's stored at here, your instance hasn't been created. So every single time you use the dot new keyword, a new instance gets created. So notice how this ID is different. Do this forever. Technically, we're creating a new instance, assigning it to the same variable. So this is not very useful, but in practice, dot new is assigning a new memory location. And then when you exit the program, Ruby has automatic memory cleanup so that data is gone. So you don't have to worry about, I don't know, taking up memory or anything like that. Cool. So dot new instantiates a new character. So we actually have a new character, but we don't have access to this variable yet. So I can't say maybe like ang.name or name if we're familiar with hashes. This is how we accessed our keys and hashes. We did the angle bracket. In objects, they're all going to be method calls. So similar to how we say .new, these methods are what is going to give access to our properties. So if I say ang.name, I should be able to get access to the name. And right now, I can't get access to it because by default, it is protected. It is private. Nothing outside of this character class has access to it. And that's the reason we have getters and setters. Getters and setters only have one purpose. You can say getters and setters, readers and writers. I think in JavaScript, it's getters and setters, and then in Ruby, it's reader and writer. They all mean the same thing. But all this reader does, or getter does, is it allows us to see what name, home, and element is for that specific instance. So that's when I can say def name It only really has one purpose. It's going to return the name. Def home returns home. Def, sorry, where's my end? Where am I? Did I miss an end? Def element returns an element. I feel like I lost an end here somewhere.
I think name stole it.
Name stole it? Okay.
Yeah.
I'm like, what happened? Okay, cool. So that's fine. We can fix it. I probably could have let it crash and burn. We could have debugged it, but that's okay. Let me move this to the right so I have more space. Panel right. I feel like this is a little bit easier because we get more space. So now I can say ing.character.new, cool. And if I say ing.name, stack level 2 deep. No. Oh, it's because, yeah. I was hoping this would, wait, what happens if I say ing.name? This is a fun error. I haven't seen this one before, but I'm trying to do unconventional things, so it's fine. I can like tell you what's going on, but I'll go through like the proper way to do this. By default, if you have name defined without making it an instance variable, it's going to treat it as a method call. So it's saying stack level 2 deep because it's recursively calling the name method over and over and over and over again. And Ruby's like, why are you doing that? I don't want you to do that. I wanted to show you like how local variables work inside of Ruby, but there's different ways to do that, and it's fine. For the world of classes, if I want my variables to belong to that instance, and technically I can do this in here. Okay, let's say name equals empty strings, sure. Like this will allow Ruby to override the method call. But the variables that I define in here, because these are local variables, it only has access within this method. And what I actually want is these variables to belong to the instance that I create. So now if I say character.new, I can say ing.name, and I get an empty string. Cool. So this is like, sure, it works. I can get some name to it, and I can assign it there. But it's not very useful if I want to make this more general and have it be available to the class. So typically, if you have properties that you define for the class, especially for the instance, we're going to make them instance variables. So we've seen local variables, which is just like name with no pre-character before it. For instances, properties that we define, we're going to make them instance variables, which is going to have a single @ sign. So this is a new type of variable that we're introducing. We're saying we're creating an instance variable name, and the scope of it is not just within the method now. The scope of it is with this whole instance, and I'll show you what that looks like. Wrong button. I still assign an empty string, which isn't really useful. I'll say ing for now, or give it some kind of value. Error tempo. Error. Cool. So before I did character.new, I have ing associated with it. Oh, I'm gonna do this real quick, and then we'll take a 10-minute break. So now, instead of making these local variables, they are instance variables. And let's see what that's going to look like. So I'm going to say ing equals character.new .character. Now if I say ing.name, it created an instance variable called name. It assigned it the value name. So if I type in ing again, ing now has this instance variable called name associated with it. And the order is a little bit weird But the main part is when you create an instance variable, it is actually tied to that memory address. And this name, Aang, now belongs to the school character. So that's the main thing you want to take away from instance variables. This ties it to the whole instance itself, which we didn't have the ability to do before with local variables because we weren't able to keep track of it outside of that method. The scope for local variables is always within that method, and that's it. And then we can technically do the same for home and element. Our model doesn't really make sense right now because it can only account for one A, but at least we're able to get some values for it. And if I type in Aang again, this character now has an element, home, and name associated with it. All right. Take some time to process this. Do y'all feel like a 10-minute break or a 5-minute break? What do you think? You can put like one hand up if you're like 5, 2 hands up if you're like 10. All right, mostly 5s. Wonderful. Let's meet back. 7 plus 5, 22. Let's meet back at 22, and then we'll pick this up again. All right. I'm gonna mute myself, and then I'll pause video for a bit. All right, recording resumed, and we're gonna kind of pick up where we left off. Before I start again, are there any questions on what we've covered so far regarding classes, getters, setters? Cool. So right now, I took away the Aang, air temple, and air since it wasn't abstract enough. We were kind of just testing things out to show you that we can set values. But if you take a look at our name, home, and element method, it only has one purpose. It only does one thing. It returns the instance variable name that belongs to this class already. So typically, getters, readers, it's only going to do one thing, and that's it. So don't try to do too many things in there. It's only going to return the property associated with it. Right now, we don't have any property defined, but that's okay. So I took away the ability to assign it variables because that's not the purpose of a getter. It just returns it. So now if we, and I added Aang equals character.new so we don't have to manually do it each time. So by the time we hit the pry, we should have this variable that's created in the line before that's available to us. So I technically have a way to now call name, but it's going to be nil because we haven't set it to be anything. And that's where setters come in. If you want to give the user the ability to set that variable, update that variable, we need to have setters associated with it. So I'm going to copy this down. The syntax for a setter is going to look very similar, except it's going to have this equal sign associated with it. And this is what our setter is going to look like. This equal sign defines a special method in Ruby. It indicates that this is a writer/setter. And what it's doing is it's taking in a name and it's assigning our instance variable name to the value we want it to. By convention, it is pretty typical to have this be the same name as the property. Sometimes students like seeing like new name here. So you can kind of like distinguish what this is actually doing. If you need to do this in the beginning to get comfortable with syntax and the flow of things, totally fine. Eventually, you will need to kind of like just have it all be the same by convention. So what the setter does is it's taking in a new variable and assigning our instance variable for that specific instance to the new value. And I defined readers for this, so I have access to get name. But if I'm like, wait, but it's no right now, let me actually assign it to Aang. You're gonna get this error, our famous undefined method error, except in this case, Ruby is actually telling us you haven't defined a writer for this, so I can't make any changes to this variable. So typically, if you ever see this name equals no method error, it means you haven't defined a setter for it. So you'll see this error a lot. I'm introducing it or having you see it a little bit, this error a little bit more, so you're comfortable and you know what to do when it's not there. So I'm going to copy this over here and define a setter for each of our attributes. So every single attribute typically, actually let me copy this over because it's faster. Typically that you have that you want your user to be able to edit, or technically in this case set, is going to have a reader and a writer associated with it. Command D, I don't know what that did. Element, cool. So we have our readers and we have our writers. I'm doing it all the long way now, so you can kind of see how to do this manually. Now we have methods that allow us to set values to this and get values. So if I say avatar.rb, I have access to ang, which has nothing. And I can say ang.name equals ang. And if I call ang again, I now have this instance variable. So I have ways to set this variable now and actually access it and use it inside of my program. And if I create a new variable, Katara, character.new, completely new instance, got the hashtag angle brackets, character object, new memory address. Awesome. And let's say I want to say Katara.name equals Katara. This character now has a name associated with it. Sweet. So more powerful now, because now I can have objects represent this data, and very easy to access data. I don't have to worry about strings. I don't have to worry about symbols. I can just say Katara.name and get access to the name. So it makes the process much easier in the world of objects to work with the data that I have. And I'll pause for a slight bit if there's any questions here. All right. And while this is still cool, and this is still easier than manually writing out my hash, it's still kind of painful saying like .name equals, and then having to like use setters to set these values. And that's where there is a special method in Ruby that allows us to create these values in the beginning when you create the object itself. Because we already know what these values are when we create the object. It's going to be whatever we have inside of this hash. And by convention, you are going to be using this method whenever you instantiate a new variable. And this method is called initialize. You might have seen this in labs already. Def initialize. And so def initialize is a special method in Ruby. And if you're familiar with other languages, you might see this referred to as the constructor. And what it does is it is an instance method, and we'll dive into what instance methods are. But it is a method that's available to us that gets called when you say .new. And it will take in the values that you pass it and assign it to and do whatever operation right when you're constructing or instantiating that object. So typically this is what we'll do here is we'll assign the name, we'll assign the home, and we'll assign the element as we create this value. So we'll say name, home, element. And we're gonna say name equals name, home equals home, element equals element. So we're taking the instance variable name, which means this is going to become this that we have here. So we're creating an instance variable. We're taking in the name passed in the initialize and assigning it respectively to their variables. So if I do this again, you're gonna get this error now that says, hey, wrong number of arguments given 0 expected 3. And you're pretty familiar with seeing this during the RSpec tests, because this is how we run our tests in our development phase. But now we're also getting this error for our initialize, because our .new on line 58 is calling the initialize, and in the initialize we're saying I need to be given a name, home, and element. So now we're bound by this requirement in order to create this instance. So in order to create a character now, we actually need to give it aim. I'm hard coding it, but we'll make this a little bit easier in a little bit. Air tempo and air. Sweet. So every single character that I create is going to have these parameters associated with it. I'm going to pass these values in. Order does matter for us now. So name, home, and element needs to be in the direct order in order to get created. Ruby doesn't really know the difference, so it'll just blindly put in whatever order you use to create this variable. But now if I say ing, I automatically have these instance variables created and assigned to this object, which is awesome because I don't have to take that extra step to assign these. Because I'm using initialize, I can automatically just assign everything here. So I would say this is pretty boilerplate for what your classes are going to look like. This already looks, let me like minimize the font a little bit so we can see more. I'm going to move all of this to the top. All right. So this character, we have our character class, which is the name of our whole model, the thing that we abstracted, has an initialize, which automatically takes in all the properties that belongs to this object. And it has some readers, so we can access that data outside of this object. I can say ing.name, ing.element. And I also have the ability to change it now. I have the ability to update it. Now realize once we introduce an initialize, our setter is actually an update method rather than an initial setter method, because that initial value is being set in the beginning. We don't need this method to set the variable now, we just need it to update it. So typically, not every property that you have inside of your class is going to be updatable in a sense. So you need to be a little bit more careful about what you allow the user or what you allow things outside of this class to make changes to. Like technically the name of a person, you can change it, I think, in the world if you want to. You can also change your home because you can move. However, the element that you're able to bend, that's not going to change. If you're a firebender, you're not suddenly going to have the ability to like bend another element. Of course, if you're the avatar, you can, but ideally, you're not going to be able to update an element. So you probably don't want to have a setter for it. So be a little bit more conscious about what you allow the user to update. By default, start with having a reader for them. And then if you realize that they should be able to update it, define a setter. Cool. Any questions on getters and setters? All right. And the next step goes back to what we did in the beginning, where we had this like adder accessor that defined our getters and setters for us. So this is something that's sort of particular to Ruby. It has shortcuts that are available to us, defined as macros, that allows us to not manually have to write our getters and setters every single time. Because I have 3 elements or 3 properties in here, not the worst to write these out, but if I had to do that for like 10 different properties, super painful. So Ruby has these macros that are available to us called adder reader, adder writer, adder accessor. And Akiko already told us what adder accessor does. It defines our getters and setters, readers and writers. Defines our getters, readers, setters, spelling, writers, and just by term, adder writers are going to write our writers and setters. And adder readers are going to write our readers and getters. I'm like getting confused with the terms. So that's all it's doing. This is going to take in a reference to the instance variable we're talking about. And it's not doing anything too fancy. It's literally just writing out this method for us. So it's going to write out def name at name end in our source code when it creates the instance of this class or template of this class. My bad. So if you have adder reader, adder writer, or adder accessor, you don't need to write these methods in here. Cool. I do want to point out one thing, which I have seen students do before. If you do accidentally end up leaving this in here, this will always overwrite whatever adder reader gives you. That's something to keep in mind because Ruby is going to treat your methods that you write as highest priority. So any method you have in here will be overwritten, which isn't the worst if you have syntax like this. But if you're like, you started writing out a name method, but you like forget to write something in it. And if I now try to access ang, oh wait, this is gonna, okay. This is like not doing anything for us right now. But I guess I could write this in real quick. Let me say name, home, element, and then we only want a writer for name and I'll leave the parentheses in here because really adder reader, adder writer is just a method. And it takes in references to our instance variables and it uses this to write out this. So let's say I have my adder readers written out, but I didn't comment any of this out, or I commented this out, but I forgot to comment this. Now, if I try to, let's see, now if I try to say ang dot name, I get nil, even though I passed in ang for my character class. And the only reason I'm getting nil here, so if I type in ang, you can see that my name has been set properly just fine from the initialize. But I get nil back because I accidentally forgot to comment this out because Ruby overwrote my getter with whatever I had below. So be paying attention to that. You can override getters and setters all you want. You just want to make sure it's what you want to do intentionally. However, with these adder readers and adder writers, you don't have to write this out. Ruby will do that for you. So that's the cool part about these macros. It makes your lives a little bit easier. And it could be very tempting to just say adder accessor and put in like name, home, and element, and just have the user be able to do everything. But I advise you not to just blanket and assign everything as setters and writers. Start out by assigning everything as readers. And once you realize you can update it, you can define adder accessors for them. Cool. So ideally, you'll say adder accessor name and home, and then adder reader element. And you can take this away. So name and home has a reader and writer, but our element just has a writer or a reader for it because we shouldn't be able to update it. Cool. This is a long class, but take a look at this, or wait, I can just collapse. Usually don't like deleting code, but I'll delete it for now. So now we've accomplished giving access to all the variables, being able to update all the variables simply by using adder readers and adder writers. So get comfortable with the syntax, when to use them, and how. Pause for any questions.
just to make sure that I'm understanding it correctly, you only have element in the reader because you don't want to update that, but you still want access to it, correct?
Yes, exactly.
Okay, cool, cool, cool.
Yep. Sweet. So I have my class for a character, got my add a reader, got initialize. And the next thing I want to talk about is this keyword that will be kind of like weird to use in the beginning that Ruby gives us, but we should at least get comfortable and familiar with, called self. Has anyone seen self come up in labs? Is it ringing a bell, or is it like one person's like a maybe? Cool. I think we'll release more content on it today too, but I want you to at least see it in the beginning before we use it, so that you know what's going on. Self is, you can think of it as like a method or just a keyword that's available to us that gives us access to or tells us where we are during runtime, and gives us access to the element that invoked whatever method we're calling, which can sound super weird in the beginning, but I'll show you like what I mean. So let's go into, I'm gonna put binding.pry in 2 different places for now. Binding.pry, 2 different places. So there's one here, and then there's one in line 37. Cool. If I run ruby avatar.rb, and when we're talking about the keyword self, you can kind of like think about the send message thing, if that helps maybe like conceptualize it a little bit better. Itself is going to represent whatever that send message is being called on. So if I say 2.send, like we did with the +2, self in this case would be 2, because self is calling the send message and passing in the variables that we want. In our case for now, we're in the initialize method, line 37, and the thing that we're initializing is the new instance that we're creating. So this can be a little bit weird, but I want you to see the syntax at least for now. Self is now representing the instance that we created. New is a little bit special, but initialize, when we're talking about types of methods and what it represents, initialize is an instance method. It's being invoked on the instance of the character that we're creating, which is this whole thing. So just by typing in self, I have access to this whole object that I just created with the variables and the values that I passed in. Super cool. This is going to become very useful for us. Just having access to this data, we can use it in many different ways anytime we want within the program, which is awesome. And this was accessible because I have, that's what self represents at that moment in time. Now I hit exit, so I'm out of the first pry that we had. And now my pry is in line 66. And I'm in my main program. So if I type in self here, I just get the main program back because I'm just like outside. I'm not within the character class. I'm just outside here. So what I want to point out there is self, like this, whatever value this is returning is going to change each time, because the value or where your binding.pry is going to be at different locations. So it's not always going to be a single value that stays the same. It's going to be different every single time. All right, so I'm gonna do one more thing to show you the final value. Let me see if I can put a binding.pry here. I usually do put statements, but I'll just do binding.pry. Cool. All right. So now it's like the final cases. So self can be 3 things. We saw it can be the whole instance where we typed in self and it gave us the whole character object that we just created, the instance of it. It could be the main program where you're not really in anything, it's just main, which is cool. And the final thing is when you're within a class. whether it's the class itself or the class method. So right now I'm in line 27, which is in here, which is in my character class. And it's going to be character because I'm within the class. And Ruby's just going through and loading up source code right now, which is why we hit this pry first. So there's really no other reason. It's just going line by line. And it's loading up this stuff and it's like, hey, there's a pry, so it put a pause there. And then it's loading up the rest of the stuff, so it loaded up the template. And now it's running line 67. So we're in initialize, which is this whole thing. Click exit. Now we're outside of the initialize, outside of that instance method, we're in line 68, which is main. So 3 different cases that self can be that you should get comfortable with testing and seeing. You'll kind of be able to guess what it's going to be over time as you get comfortable using this keyword or using this method, whatever makes most sense to you. But at the same time, if you're like, I have no idea what it is, do what I did. Just put a binding.pry in there. And you're like, what is self going to represent in this case? Put a binding.pry, type in self, see what it is, and then figure out what's available to you.
So itself, are you just trying to figure out where you are in everything? And that's it? Because, okay.
Yeah, for us, it's mainly going to be figuring out where we are. And also, if we're inside an instance method, it's going to be super powerful because we have access to this data. So if I'm in an instance method and maybe I'm like, oh, I need to be able to figure out what this data is, so maybe I can pass it into a different method, which is exactly what we're going to be doing. You don't have to do anything too fancy to get that value. You can just type in self, and that whole instance is available to you, which is like sort of weird, but also super cool.
But couldn't you just also type in, like, I think this is ang, and still have the same information available when you're in binding.pry?
Yeah, that's a good question. I can do that if I'm in the main program where I have access to ang.
Okay.
If I'm in, let's see, so I'm in main right now because I'm in my last pry. I can type in ang and I have access to this character. Cool. If I exit out of this and I go back to my initialize, so I'm in my character class, line 27, technically nothing's been created, but I don't have access to ang because ang hasn't been created yet. If I go to the next pry inside of my initialize and I type in ang, even though I'm inside of the actual instance for ang, I don't have access to ang because that's in my main program. If I want to get access to who ang is, who this represents, I have to use self. So if I'm inside of the instance of the class, the only way I can get access to that data is through self.
Okay, so when you can't access that data through binding.pry, then you could do it with self. Cool.
Yep.
Okay.
Yeah, thank you for clarifying that. Ask all the questions now because this, I totally understand if this is like, what? There's another way to get around it, which like you can pass in parameters. So you could be like, let me just pass in ang. But if you're within a character class and ang is the instance, then that's kind of like doing double work because you don't need to pass in ang because you have access to self.
A question, if you're in main and you have multiple instances, what would self do? Or would you have to do like ang.self to get to that instance?
Yeah, so let's see. If I'm in main, self is always going to be main. So I actually have no way to get access to ang unless I create variables for it. Yeah, so I'm in my main program right now. Self is, well, I guess I can say self.ang. Nope, never mind, I take that back. Cannot say self.ang. Self is just representing the main program. So the only way I can get access to the instances I created is by storing it in variables. I feel like there might be a hack for that, but that might be like too deep for what we're doing. So if I create a variable for Katara, And Katara, I think, is from the Southern Water Tribe. And water. So the only way I have access to this instance is because I stored it in a variable called Katara in the main program. So main has access to Aang, the variable, and the variable Katara, but not both. All right. So self is awesome, super powerful, takes some time to get comfortable with it. And you'll figure out, like, we'll kind of work through how we can use it inside of our program. Sweet. Now, the first way that you'll see it be introduced, let me go back to my README so I can, there's like one final thing I want to talk about, but I want to see if there's any like important things that I'm missing. I feel like we got through most of these except class stuff, which we'll do now. All right. I'll pause to see if there's any final questions about code we have here. And then I'll transition into introducing our final new concept before I wrap up, which are going to be class stuff, class methods, class variables. Cool. So we saw local variables, which is just like name, or not even name. Technically, name, home, and element here are local variables. Has no @ sign. We saw instance variables that ties the object we created or the variables we created to that instance. The last type of variable that you want to be comfortable with using are class variables. What do I want to call this? I can call this anything. I'll call this characters, which can feel kind of convoluted right now. But class variables are represented by this double @ sign. So anytime you see this double @ sign before the variable name, it indicates a class variable. And just like an instance variable is tied to that instance, a class variable, it's tied to that class. So I think the easiest way to see this in our analogy, for Blueprint, it's kind of weird because Blueprint is just like a piece of paper. But if it's like a program, maybe, there's specific things that a Blueprint needs to keep track of that a house wouldn't. So if there's any changes that need to be made, or if we need to keep track of all the houses in the district, the houses themselves don't really care about each other because they're like, hey, I'm my own thing. People live in me, cool. But the district or the Blueprint or any changes that are happening is something that will be on the Blueprint level. It's easiest to see with the car factory analogy. Like every single Toyota car that's been made doesn't really care about other stuff that's happening around the factory. But the factory itself is going to have its own set of properties and its own set of methods to keep track of all the cars that maybe you created, to keep track of all the changes that are happening in the factory itself that won't be at the instance level. So that's where class variables become important. It's going to be methods or variables that belong to the class itself and not at the instance level. So let me draw this out real quick. Can I do a box? Like, how do I draw a box? Nope. Okay, I'm just gonna draw, oh yeah, simple class that I'm using for a box. Nope. Simple shapes, cool. So this is my class text character. What's happening? Nope. Never mind. I just wanted to. Oh my god, this is too much work. Whoa. Why can't I type in character? The text is super weird. Never mind. Oh. White? Is that white? Okay. It's kind of weird to see. But let's say this whole thing represents our character class, and this character has a bunch of different methods inside of it. And there's our instance class, got distracted by how weird it is to use this platform. But our instances, our character instances, oh my God. This platform has given up on me, so I'm just gonna talk through this. Oh well. So we have our character stuff, our factory stuff that is only within the scope of here, and then we have our character instances. I want to distinguish between the separation, or I want to separate these two out because our instances have separate methods and properties associated with it, and our characters have separate properties and methods associated with it. We technically haven't defined any class methods here. But one of the most conventional class methods that you're going to see is a variable that's going to keep track of all the different instances of that specific object that has been created. So I can create a characters variable, and it only has one purpose. It's going to keep track of all the characters that we've created inside of this, inside of our domain right now. Let me call this out. And one thing I want to say about our attr accessor, attr reader, it only works for instance methods. If you have class methods or class variables that you've declared, you need to write your own getters and setters. So we need to write our own getter, at least for now, for characters. So we're going to say def characters end. And similar to initialize, if I just write character on its own, it's going to be automatically by default an instance method. To make this available to the class level, I have to attach the self keyword before it. So anytime you see the self dot in the method signature, it indicates that it's a class method. And then just like a getter, it's only going to do one thing. It's going to return the add characters. So now our character model has one method in there called characters. It froze. That allows us to call the character variable and return it. So now we have a characters variable, class variable, and we have a characters class method. And if I actually want to call this, I can't call it on Aang or Katara because these are instances of a character. I have to call it within the character class. So I'll say character.characters, and it'll return my empty array. I feel like that was a lot to go through in like 5 minutes with my UI failing. But how are we feeling about class variables, class methods?
Do the names eventually go into the array itself, or how do then?
Yeah. That's a good question. So we started out, we have a characters variable, we have a method to return it, but how the heck do we actually put in it? Put these names in, and that's where self comes in. Because as we saw in the initialize, when we type in self, we got access to the whole instance. So we can automatically say characters, you can say characters.push, you can use the shovel, whichever you want, and we're gonna type in self. Might feel a little weird, but self represents the whole character instance we just created. We're gonna take it and we're gonna put it in our characters variable.
Don't you need the double? Okay, there it is.
If I made it a local variable, it would have been useless. Well, maybe not entirely useless. We would have seen some value. So now if I say character.characters, I have access to all the things that I've created, which is awesome. So I have a way to access all the characters within my class itself. Like one of you asked before, how can I access all the instances inside of my main or how can I access all the instances inside of character? The scope is each within their own. However, now in my main, I don't even need to keep track of these variables anymore. I have access to this characters variable that's being created every single time I initialize something. In the initialize is probably going to be the most efficient way to store this variable because you create it, you store it in characters, you have access to it until you quit the program, which is super powerful. Sweet. So I am going to upload this code, and you'll have a chance to kind of look through it. This is pretty similar to what I prepped, except my prep has a lot of tests in there, so you can look in there if you want to. But we did cover a lot within this lecture itself, kind of like introduced objects, getting comfortable with Ruby syntax for creating classes, getting comfortable with domain modeling, worked with instance methods, class methods, add a reader, add a writer. So it's a lot. And if it's not completely like gelled in your brain, it's totally fine. We'll do more practice creating these classes and getting comfortable with all these different macros and all these different methods we're creating. So we'll practice this more this afternoon too. I'll give you a couple examples to work through together as a group so you can kind of like implement it, and it'll be great. This afternoon, we're going to transition into relationships and creating more objects and actually associating them with each other. I'm still staying in the world of Avatar, so we'll figure out how to do this within our Avatar land. Any final questions, thoughts, feedback? Sweet. This was Intro to Object-Oriented Programming. I'm going to stop recording.